Welcome to another episode of Tutorials with Ike. My name is Isaac Osafo Jr., the Vice President for the Association of Business and Nutrition Students. If you're new to this channel, don't forget to hit the like button, subscribe, comment, and share. And today we are going to be looking at correlation and regression under business statistics. And this might be the last topic I'll do under business statistics because I think this is the last topic in the syllabus. So this might be the last time some of you will watch this channel. So in case this will be the last time, I'd like to inform you guys that next year I'll be aspiring for SRC president at UPSC. So if you're a student at UPSC, your vote will be appreciated next year. Thank you very much. So as I said, you're going to look at correlation and regression, and this topic is actually one of the easiest topics in business statistics as well. So we're going to look at it and solve a trial question which might come this year for you guys. You get it? So now, before I even solve the question with you guys, I'll just like to explain some few things about correlation and regression. So correlation and regression just shows you the relationship between two variables. You get it? So if this one increases, what will happen to the other variable? If the other variable decreases, what will happen? You get it? So you just want to see if they are positively related and all that. Do you get it? And under correlation and regression, there are two main methods we use. We use the Pearson's correlation coefficient and Spearman's round correlation. So those are the two types you are going to be looking at. If you have no idea in correlation and regression, don't worry. After this video, you understand it step by step because I'll try my best to take it very slowly. You get it? All right, now let's take the trial question. Okay, so I'm reading it. It says a study was made on the amount of converted sugar in a certain process at various temperatures. The data were coded and recorded as follows. So you have temperature into bracket X, then you have 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and 2.0. Then converted sugar into brackets Y. So you have 8.1, 7.8, 8.7, 9.8, 9.5, 8.9, 8.6, 10.2, 9.3, 9.2, and 10.5. Then they said NB use two decimal places. Using a simple linear regression equation of the form where alpha is the y-intercept, beta is the slope, and e is the error term. I. Find the values of alpha and beta. II. Interpret the results from I above. III. Estimate the converted sugar when the coded sugar is 1.75. Ivan. Estimate the Pearson's correlation coefficient and interpret your results. Vin. Estimate the coefficient of determination and interpret your results. Then I. List three properties of the correlation coefficient. So this is a full question that can come for you guys. You get it. This one is under Pearson's correlation coefficient. Most of the questions are from Pearson's correlation coefficient, but then they can bring a question from Spearman's as well. So we'll solve that after this one. We'll use Spearman to also solve this same question so that in case for some reason they bring Spearman's round correlation, you'll be able to do it. You get it. Now, if a question comes on this, that is Pearson's correlation. So I'm going to start with Pearson's correlation coefficient. You get it? Because most of the questions come from it. And this particular question too is under Pearson's correlation coefficient. Now, if they give you the question and it's under Pearson's correlation coefficient, the first thing is that you just draw your lines and all that. Then the first one is your X. Then the second one is going to be your Y. Then the third one is going to be X squared. Then the fourth one is going to be Y squared. Then the last one is going to be XY. Get it? So don't forget, if you see any question on Pearson's correlation coefficient, any question, just write these 5 things: your X, Y, X squared, Y squared, and XY. You get it? Write these 5 things. Now your X will be given to you, and this one they said your X is the temperature. So the values were so they give you the X values. That one they give it to you horizontally like this, but it's better to write it like this vertically. You get it? So now the X values which have already been given to the question, I'm just going to write it again here. So the first one, we had 1.0, which was in the question. The second one to 1.1. The third one, 1.2. Then the fourth one, 1.3. And the next one, 1.4. Then the next one, 1.5. Then the next one, 1.6. Then the next one, 1.7. Then the next one, 1.8. Then the next one, 1.9, and the last one 2.0. So these are for our x values, which is that of temperature. Now let's go to the next one, which is y. That's our converted sugar. So that one, so they've given us all the values. So we just rewrite it. You get it. So the first one is 8.1. Then the next one, 7.8. Then the next one, 8.7. Then the next one, 9.8. Then the next one, 9.5. Then the next one, 8.9. Then the next one, 8.6. Then the next one, 10.2. Then 9.3, 9.2, and 10.5. All right. So this is what they gave us in the question. So the x values and y values, each value I've written on the board is already in the question. So I just wrote the same thing on the board. So as I said, after you've written it, the first thing you find for is your x squared. You get it? So that one has not been given to you. So you just have to square all the x values. You get it? So now let's start squaring the x values. The first one, they gave us 1.0, which is the same as 1. So when you square 1, 1 squared will give you 1. So you do all on the calculator. The next one, 1.1. When you squared 1.1, you should be getting 1.21. So when you square 1.1, you should be getting 1.21. Then the next one, 1.2. When you square it, you should be getting 1.44. Then the next one, 1.3, you should be getting 1.69. Then the next one, 1.4, you should be getting 1.96. Then the next one, 1.5, you should be getting 2.25. Then 1.6, you should be getting 2.56. Then 1.7, when you square it, you should be getting 2.89. Then 1.8, when you square it, you should be getting 3.24. Then 1.9, when you square it, you should be getting 3.61. Then the last one, 2.0, when you square it, you should be getting 4. 4 or 4.0 is the same thing. So what I just did, I just squared the values, all the x values. So 1.0 squared give us 1. 1.1 squared give us 1.21. 1.2 squared give us 1.44. 1.3 squared give us 1.69. 1.4 squared give us 1.96. So I just squared all these x values, then they gave me this. So whatever x values they give to you in the question, you just draw on that table for it, then you square all of them. You get it. After you squared for the x values, you also square for your y values too. You get it. So they've given you all the y values in the question. So each y value, just square all of them one by one. So now we start with 8.1. So 8.1 squared, when we square it on the calculator, we should be getting 65.61. 65.61. You get it. Then the next one, our next y value is 7.8. So when we square 7.8, we should be getting 60.84. 60.84. Then the next one, 8.7. When you square 8.7, you should be getting 75.69. 75.69. And the next one, 9.8. When we square it, you should be getting 96.04. 96.04. And the next one, 9.5. When we square it, you should be getting 90.25. 90.25. Then the next one, 8.9. When you square 8.9, you should be getting 79.21. 79.21. Then the next one, 8.6. When we square it, you should be getting 73.96. Then the next one, 10.2. When we square it, you should be getting 104.04. Then the next one, 9.3. When we square it, you should be getting 86.49. Then the next one, 9.2. When we square it, you should be getting 84.64. Then the last one, 10.5. When we square it, you should get 110.25. So now we are done squaring the y value. So what I just did with the y values here, I just squared them, you get it. So 8.1 squared, I got the 65.61. 7.8 squared, I got the 60.84. 8.7 squared, I got the 75.699. So I just squared all these values. What I got, I wrote it here. As simple as that. You get it. Now we find for the last one, which is xy. So xy means x times y. These are your x values, these are your y values. So this times this, this times this, this times this, all of them. So we start with this 1.0 times 8.1. 1.0 is the same as 1. So 1 times 8.1 will obviously give us 8.1. Then the next one, 1.1 times 7.8, that should give us 8.58. 8.58. Then the next one, 1.2 times 8.7 should give us 10.44. Then the next one, 1.3 times 9.8 should give us 12.74. Then the next one, 1.4 times 9.5 should give us 13.3. Then the next one, 1.5 times 8.9 should give us 13.35. Then the next one, 1.6 times 8.6 should give us 13.76. Then the next one, 1.7 times 10.2 should give us 17.34. Then the next one, 1.8 times 9.3 should give us 16.74. Then the next one, 1.9 times 9.2 should give us 17.48. Then the last one, 2.0 times 10.5 should give us 21. You get it? So now we just multiply the x and the y value. So this times this give us 8.1. 1.1 times 7.8 also give us 8.58. 1.2 times 8.7 also give us 10.44. So this times this, then whatever we got, you get it. Now the next thing, after you found for all the values, the next thing you do is that you find the summation of all of them, or the sigma of all of them. So for x, you add all the x values, then you put your answer there. For y, you add all the y values, you put your answer there. For x squared, you add all the x squared values, put your answer there. For y squared, you add all the y squared values, put your answer there. Then finally, for x, y, add all of them, then put your answer there. So let's start with x. So sigma x, we call it sigma x. When you see sigma, it means summation. You get it? So 1.0 plus 1.1 plus 1.2 plus 1.3 plus 1.4 plus 1.5 plus 1.6 plus 1.7 plus 1.8 plus 1.9 plus 2.0 should give us 16.5. So 16.5. That's our sigma x. So our summation of x. Now let's go to sigma y, which is when we add all the y values. So sigma y is equal to, so let's add all of them. 8.1 plus 7.8 plus 8.7 plus 9.8 plus 9.5 plus 8.9 plus 8.6 plus 10.2 plus 9.3 plus 9.2 plus 10.5 should give us 100.6. So 100.6 or 100.6. Then now let's go to the x squared value. So we add all the x squared values. 1 plus 1.21 plus 1.44 plus 1.69 plus 1.96 plus 2.25 plus 2.56 plus 2.89 plus 3.24 plus 3.61 plus 4 should give us 25.85. So sigma x squared should give us 25.85. Then let's go to the y squared value. So sigma y squared, meaning we are adding all the y squared values. So 65.61 plus 60.84 plus 75.69 plus 96.04 plus 90.25 plus 79.21 plus 73.96 plus 104.04 plus 86.49 plus 84.64 plus 110.25 or 110.25 should give us 927.02. So 927.02. That's our sigma y squared. And finally, our sigma xy. So when we add all the xy values, which is 8.1 plus 8.58 plus 10.44 plus 12.74 plus 13.3 plus 13.35 plus 13.76 plus 17.34 plus 16.74 plus 17.48 plus 21, and that should give us 152.83. All right, so now that you found for the total of all of them, the total of x, y, x squared, y squared, and xy, we can now start answering the question. So let's start. The I says find the values of alpha and beta. So if they ask you for this, you just have to know the formula for a simple linear regression. Now, for business statistics, you're only going to deal with simple linear regression. So the formula is just one, you get it. Hopefully, next 2 semesters, we'll be looking at quantitative methods. And for now, you're going to look at multiple linear regression, which is far more difficult than this. But this one is just the simple one. And the general formula for a multiple linear regression is, let me write it here. So the formula is y is equal to alpha plus beta x. You get it? So this is, you can add your error term, but for this one, they wouldn't usually give you any error term. So you can just leave it as alpha plus beta x. You get it? So you can add plus e. So this is just a general formula, and thankfully they'll give you this formula in your formula sheet. So you don't need to chew any of the formulas you're about to do. They'll give you every single formula. So you just need to solve more questions. You get it? So when you see the formula, you just know how to solve it, because this will be given to you and all that. Yeah. So at least when you see the formula, you know that it's for this one. So this formula will be given to you. So don't even worry about it. You don't need to bring the e to, it's not compulsory, but you can also add it. But they'll give it to you. So yeah. Okay, so the I says you should find the values of alpha and beta. Now put this in your head. If they ask you to find for alpha and beta, you cannot find for alpha without finding for beta. You get it? So in other words, you have to find for beta first before you can get your value for alpha. You get it? This is beta, this is alpha. So you have to find for the b first before you can find for the alpha, which is like the A sign. You get it? So now the formula for beta 2 will be given to you. So this one, you just need to be solving them regularly so that you'll be used to it. You don't need to chew any formula. They'll give you every single formula you're about to use. So this formula will be given to your in your formula sheet. So in the formula sheet, you have this formula as n sigma xy minus sigma x sigma y over n sigma x squared minus sigma x, then you close the bracket squared. Yes, this is it. So this formula will be given to you. So when you check your formula sheet given to you in exams, you see this formula. So you find the beta. When you find the beta, then you find the alpha. So after you find the beta, I'll give you the formula for the alpha. All right, so now the formula is n, and n is the number of variables you've been given. You get it? So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they are 11. So our n, let me just write it somewhere. Our n is equal to 11. So you just count the x values or the y values. You get it? So our n is 11. So now that we have the values for all of them, the total for all of them, you can just substitute it in the formula. So here, our beta is going to be, so n sigma xy. Our n is what? 11. Then into brackets sigma xy. Sigma xy is here. You get it? So you've already found sigma xy. You got it as 152.83. So into brackets 152.83. Then minus sigma x sigma y. So sigma x is 16.5. So into bracket 16.5. Then times sigma y. Sigma y is 100.6. So times 100.6. Then for our denominator, we have n again, which is our 11. Then into brackets sigma x squared. Sigma x squared is 25.85. So 25.85. Then minus into brackets sigma x 16.5. 16.5. Then squared. Now, please take note of the square and all that. Now, if you see sigma x squared is different from the sigma x and the square is outside. Please take note of it. If the square is outside, it means you just take only the sigma x, then after you square it. But if you see sigma x squared and there's no brackets, it means they are talking about this one. You get it? So please take note of that, or else you might make a mistake. You get it? All right. So from here, you can just punch everything on the calculator. So when you punch all this on the calculator, for the numerator, we have 11 into brackets 152.83 close brackets minus into bracket 16.5 close bracket into bracket 100.6 over 11 into bracket 25.85 close brackets minus into bracket 16.5 close bracket squared. So when you punch all this on the calculator, you should be getting 1.75. You might get something after the decimals, but the question said to 2 decimal places. So please don't forget, if the question gives you a preamble that is to 2 decimal places, any answer you get, you have to leave it to 2 decimal places. You get it? So this is 1.75. That's when it's in 2 decimal places. So now you found for your beta or your b, which is 1.75. Now, they said find the values of alpha and beta, so you have to find the value for alpha. So the value for alpha 2 will be given to you in the formula sheet, so no need to stress about it. So when you look in the formula sheet, you have your alpha to be sigma y minus beta sigma x over n. Yeah, so this is the value for, the formula for alpha. And you see, it includes beta. That's what we just found for. That's why you can't find the alpha without finding for the beta, because alpha includes beta itself. So always you find for beta before you find for alpha. You get it? All right, so now our alpha will be equal to sigma y. We already found for sigma y here, which is 100.6. So 100.6 minus our beta. We just got our beta to be 1.75. So minus 1.75 times our sigma x. Sigma x, we got 16.5 into bracket 16.5. Then over n. N is 11. We already have it here. So over 11. So you can punch all this on the calculator. When you punch it, you should be getting 6.52. That's to 2 decimal places. Don't forget every answer we get, we are leaving it to 2 decimal places. So when you punch all this on the calculator, 100.6 minus 1.75 into brackets 16.5 all over 11, you should be getting 6.52. That's when you leave your answer to 2 decimal places. So please, I hope you get it. So don't get scared when you see this question. All the formulas are in the formula sheet. Just go to the formula sheet. You see all these formulas. You see the formula for beta. You see the formula for alpha. Like, you see literally everything you would need to solve for the question. So the only thing you need to do is to solve more questions. Once you solve more questions, when you are solving them, you'll be used to it. So you know how to go about it. You get it. So now you found for the value of alpha and beta as well. So you are done with the I. So let's go to I says you should interpret the results from I above. Okay. Let me clean the solution so that we do it. So I won't clean the beta for now. I want to use it to explain something. Now take a look at something. I deliberately did not clean the values for alpha and beta. Now alpha we got 6.52 and beta we got 1.75. And I told you that this is the general equation. Y is equal to alpha plus beta x plus e. So if you want to substitute it into it, you are now going to be getting like something like y is equal to alpha is here 6.52. So 6.52 plus beta. Beta is here 1.75. 1.75, then we add our x. You don't need to add the error term since they didn't give us error term. You get it? So you can just leave it like this. Okay, now we can clean this. You get it? You already know from this that, so here we just substituted y is equal to alpha plus beta x plus e. This one to also be given to you, so we just mean that alpha 6.52, which you just solved for, and our beta 1.75, which you just solved for. And now they are saying we should interpret the results. So you are asked to interpret this. Now if you want to interpret this, you have to remember what y was standing for and what x was standing for. Now in the question, now let's go back to the question. The question, they said temperature into brackets x. So our x were the values for temperature. So just put to your head that this x is temperature. So let me use an arrow to represent it. Temperature. So x is temperature, and y, let me also use an arrow to represent it. Y was what? Converted sugar. Converted sugar. So now before you can even interpret it, you have to know what y and x is. So in the question, they'll always give you the value for x and y. Sometimes it can be age, boys, whatever. But this time they give you your x to be temperature and they give you your y to be converted sugar. So now if you want to interpret this, say you should interpret the alpha and beta. So now take a look at something. If we make x 0, let's assume that you want to make x 0 in this. What are we going to get? We are going to get y is equal to 6.52 plus 1.75 into bracket 0. Now I want you guys to punch all this on the calculator so that you understand something. Now when you punch all this on the calculator, 6.52 plus 1.75 into bracket 0. So we made x 0. Realize that you are going to get 6.52 because this 0 will multiply this, then all here will be 0. So you'll be left with 6.52. Now what does that tell you? It tells you that when x is 0, your converted sugar, which is y, when x is 0, y is going to be 6.52. I hope you are paying attention. When we made our x 0, we got our y to be 6.52, and 6.52 was our alpha. Do you get it? And now y, we've already said that y is the converted sugar. So when x is 0, our converted sugar is 6.52. So now if you want to interpret this, you can just say when x, or when the temperature is 0, our y, which is our converted sugar, will be 6.52. So when the temperature is 0, our converted sugar will be 6.52. So I repeat, when temperature is 0, temperature is our x. So when x is 0, then the converted sugar will be 6.52. You get it? So that's how you always interpret the alpha. So even if you don't know what they are talking about, just put in your head, when x is 0, when you get a value for alpha, when x is 0, your y will be the value for alpha, which is the 6.52. I hope you've all understood. Alright, so now that you've understood that for alpha, we can just clean this. No one will ask you to solve for this. I just wanted you to understand this, because probably if I just interpreted it just like that, you might have been confused. So I just wanted to use this to explain, but no one will ask you to do this. You get it? So I can clean this for now. So now we've interpreted alpha. Now let's go to our beta, which is 1.75. So now if you want to interpret this, now watch something. You realize that x is our temperature, just like we said, and y is our converted sugar. So now, if you want to know what b is, or beta is, if you want to interpret the beta, now just put this in your head. If let's say x is 1, let me just write it here. So if x is 1, so you are going to get y is equal to 6.52 plus 1.75 into brackets 1, which is the same as plus 1.75. Now if x is 2, it means it's going to be 1.75 into brackets 2. If x is 3, it's going to be 1.75 into brackets 3. You get it? So obviously, I'm going to be multiplying by 1.75. Do you get it? So what that means is that for every increase in x, which is our temperature, it leads to a 1.75 increase. Do you get it? So for every increase in our x, it leads to a 1.75 increase, because once you increase it, you're going to multiply it by 1.75. You get it? So if you want to interpret the beta, you can just say for every increase in x, it leads to an increase in y by 1.75, because eventually here is going to increase by 1.75. The 6.52 there is already there. That one there, you found it, so it's always constant, but obviously you're going to be multiplying the 1.75 by whatever value you get for x. So if they say let x be this, then you're going to multiply it by that. You get it? So for every increase in x, and x is our temperature, so for every increase in the temperature, so you can just say for every increase in 1% of the temperature. Okay, we don't measure temperature in percentage, we measure temperature in degrees. So every increase in 1 degree Celsius, you can just say Celsius. So every increase in 1 degree Celsius of temperature will lead to an increase by 1.75 in converted sugar. You get it? So I take it again. For every 1 degrees increase in temperature, it leads to an increase in converted sugar by 1.75. I hope everyone has understood it. Now let's go to III. So the III says that we should estimate the converted sugar when the coded sugar is 1.75. Okay, so I can clean this. They are saying that you should estimate the converted sugar, which is our y. So what is y when the coded sugar is 1.75, right? So when x is 1.75, that's what they are saying. You get it? So we already said that you just have to multiply the x by it. So we are going to get, so our I is going to be y is equal to 6.52 plus 1.75 into brackets our x, which is what they just give to us, so 1.75. So always this part, just whatever they give it, that would be your x most of the time. You get it? So whatever they give you, they ask you for any value, just replace it with x. You get it? So when you do that, you are going to get y is equal to 6.52 plus 1.75 into bracket 1.75. And when you do that, you should be getting 9.58. That's to 2 decimal places. You get it? So when you solve this on the calculator, and when you change it to 2 decimal places, you should be getting 9.58. Don't forget we are leaving our answers in 2 decimal places as it was requested by the question. You get it? So this is how you go about it. So anytime they ask you for the y, which is the converted sugar. When anything is any particular value, you get it, just change the value to x, just change the x to that value. You get it? When they ask you for y, which is a converted sugar, just change the x to that particular value they give to you in the question, then you substitute it and solve for it. You get it? So when we did that, you are getting 9.58. All right, you are done with the III. Now let's go to Ivan. He said we should estimate the Pearson's correlation coefficient and interpret our results. All right, so now let me clean this part so that we can do it. And this part carries a lot of marks. You get to the Pearson's correlation coefficient, and they'll also give you the formula for this in the formula sheet, so no need to worry. So the formula for Pearson's correlation coefficient is, so you represent it by R. So the formula in the formula sheet, I'm just going to write the same thing in the formula sheet, is N sigma xy minus sigma x sigma y, then over the square root. So the denominator, everything under the denominator is a square root. So you are getting something like this. So n sigma xy minus sigma x sigma y over, then the denominator, you have the square root of n. So you open a big bracket, then you have n sigma x square minus into brackets sigma x, then close the bracket square, then you close the big bracket, then you open another big bracket, then you have n sigma y squared minus into bracket sigma y, then close the bracket square. You get it? Then you can also close your big bracket. So this particular formula will be given to you in the formula sheet. You get it? So I just repeated the same thing in the formula sheet for you. Get it? So no need to chew all this. All right, so now let's find for our Pearson's correlation coefficient. So we represent that one by R. Yes, so we represent it by R. So our Pearson's correlation coefficient is, that's for the Ivan. So this one is just formula work. So we just input the values in it. So the formula is n. N is what? Let me rule the fraction. So n is what? 11. Then sigma xy. What is sigma xy? Is here 152.83. So into brackets 152.83. And close brackets. Then minus sigma x sigma y. What is sigma x? 16.5. So into brackets 16.5. Then times our sigma y. Our sigma y is 100.6. Then over, we have square root. So everything at the denominator will be under a square root. Don't forget. You get it. Then you open a big bracket. So you open a big bracket. Then you have n. N is 11. Then times sigma x squared. Sigma x squared is 25.85. So 25.85. Then minus into brackets sigma x. Sigma x is 16.5. Then close the brackets, then square. You get it? Then close the big brackets. Then you open a big bracket. This one. Okay, so you open the big bracket, then n. So n is 11. That is here. Then sigma y squared. Where is sigma y squared? 927.02. So into brackets 927.02. Then minus into brackets. So minus into brackets. Where is it? Sigma y. What is sigma y? 100.6. 100.6. Then square. You get it? So let me realign like this. So all this is under the square root. Get it? So this is what you are getting. So here, please take your time, or else you might make a mistake. You get it? All right. So now let's break this down. Here, I'll not advise you to punch everything on the calculator. It's best to break it down. You get it? So I don't make a mistake. All right. So our Pearson's correlation coefficient, our R is equal to 11 into brackets. So I'm doing only the numerator first. So 11 into brackets 152.83 close brackets minus into bracket 16.5 close bracket into brackets 100.6. So only the numerator, the top one, should give us 21.23. 21.23. So that's only for the top. I've not done anything on the down. Then for the down, you have square roots. Then you have something like square roots. For the down, you have something like square roots of. So you have two big brackets. So this one and this one. So let's do the first one. So from here to here, you have 11 into bracket. So 11 into bracket 25.85 close bracket minus into bracket 16.5 close bracket square. So only this part should give us 12.1. So into bracket 12.1. Then close brackets. The second one from here to here, you have 11 into brackets 927.02 minus into brackets 100.6 square. So only this part should also give us 76.86. So you can punch all this on the calculator, and when you punch all this on the calculator correctly, you should be getting 0.70 to 2 decimal places. You get something like 0.69615 something. But remember, everything is to 2 decimal places as it was requested by the question. So 0.69615, when you change it to 2 decimal places, you should be getting 0.70. You get it? So that is going to be our final answer. 0.70. So yes, our final answer is 0.70. And the question asked us to interpret it, right? So you interpret our results. Now put this in your head. If you get, after you solve for Spearman's correlation coefficient or Pearson's correlation coefficient, any of them, once you solve for any correlation coefficient and you get R is equal to 1. So if you get anything that is exactly 1, then you conclude. That's when they ask you to interpret for a result. You conclude that it's a perfect positive relationship. You get it? It's a perfect positive relationship, or there's a perfect positive relationship between the variables. You get it? That's your x and y. Now, if you get your r to be -1, that's exactly -1, then it means there's a perfect negative relationship between the two variables. Now, if you get r to be 0, it means there's no relationship between the two variables. And if you get r to be greater than 0, but r is also less than 0.5, then it means there's a weak positive relationship. And lastly, if you get r to be greater than 0.5, but it's also less than 1, then it means there's a strong positive relationship. You get it? So this one like this, r is greater than 0.5, but it's also less than 1. So you see there's a strong positive relationship between the two variables, which is x and y. You get it? So that's how you solve for Pearson's correlation coefficient. All right, now let's move on to the next one, which is VIN. Estimate the coefficient of determination. All right, let me clean the board so that we can solve for it. Okay, so coefficient of determination represented by CD. So the formula is r squared times 100%. This would also be given to you in the formula sheet. You get it? So r squared is what we just solved for, which was our Pearson's correlation coefficient, and we got 0.70 when we rounded it to 2 decimal places. I hope you've not forgotten that. So now it means our coefficient of determination will be r squared, which is 0.70 squared times 100%. And when you solve this on the calculator, you should be getting 49. So 49%, you get it. So here, whatever you get at Pearson's correlation coefficient, just come and square it, then times 100%. That's if they ask you for the coefficient of determination, you get it. Just whatever you get for the correlation coefficient, then square it times 100%. So we are getting 49%. Do you get it? All right, so we are done with the VIN. Then the VIN I says we should list 3 properties of the correlation coefficient. Okay, so this one, the first one you can talk about is that it ranges from -1 to +1. You get it? So that's one property of it. So the next one you can also talk about is that if you get a positive value, it means there's a positive relationship between both of them, meaning that as x increases, y also increases. You get it? But if you get a negative value, it means there is no positive relationship between both of them. Or as x increases, then y decreases. You get it? So they are inversely related. You get it? So that's the next one you can talk about. Now the last one you can also talk about is that if your answer is closer to +1, or the closer your answer is to +1, it means there's a strong relationship between the both variables. But if your answer is closer to 0, then it means there is no relationship, you get it, or there is no strong relationship. So those are the three things you can talk about. All right, so we are done. Now, I also mentioned that they can also give you Spearman's rank correlation, you get it. So they can ask you a question like, that's under this same thing. Using Spearman's rank correlation coefficients, calculate and interpret the relationship between the two variables, which are x and y. So in case you get a question on Spearman's rank correlation coefficient, let me just show you how you do it. So for that one, we can clean this part. And for that one too, we will not need x squared, we will not need y squared, we also not need xy, you get it. So we are going to clean this one. So let me just clean them. All right, so as I said, when it comes to Spearman's rank correlation coefficient, you don't need the x squared, y squared, and xy. You get it? So we are now about to solve for Spearman's rank correlation coefficient. So if a question comes on it, you just write your x values, your y values. Now the next thing you write is the rank of x. You get it? So rank of x. So I can just do rank into brackets x. Then the next one you write is rank of y. Get it? Rank of y. Now after you write the rank of y, the next one you write is difference, or d. Now your d is the rank of x minus the rank of y. You get it? So you write d into brackets. So you can make it r of x minus r of y because of space. You get it? Then the last one you write is your d squared. So d squared. So whatever you get for d, you just square it. So I repeat, if you see Spearman's rank correlation coefficient, this is how you do it. This is only for Spearman's rank correlation coefficient. The first one we did is Pearson, you get it, but this is Spearman. So Spearman's rank correlation coefficient, you write your x values, which have already been given to you in the question. Then write your y values too, which have already been given to you. Then the next one is the rank of x. Then the next one you write is the rank of y. And the next one, d into brackets, that's the rank of x minus the rank of y. So whatever you get for here, you subtract it minus this one, you get it. Then after you get those ones, you are going to square them. You get it. So don't worry, we are going to do it step by step. Now, what is rank of x? So now you are going to rank the values of x. So rank of x. So you're going to rank the values of x. You can either do it in ascending order or descending order. I prefer to do it in ascending order because it's much easier. If you also feel like descending order too is easier for you, you can also do it. So if I'm arranging in ascending order, I'm going to start with the smallest to the biggest. So the smallest is going to be 1, get it? Then the biggest is going to be this one. There are 11, so the biggest is going to be 11, get it? So I'm going to be ranking it from smallest to biggest, get it? So 1, 2, 3, 4. Then as this is increasing, and I'll also be increasing the number, you get it? Then rank of y, so I'm also going to be ranking the y value. So I'll start with the smallest and I'll be increasing, you get it? So that's how we go about it. All right, so now let's start with rank of x. So as I said, I'm going to be doing it in ascending order, you get it? So you can also do it in ascending order if you feel like that one will be easier. So we start with the x values. Which one is the smallest? So 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2.0. So this one, you realize that they've already done it in ascending order for you already, you get it? So the first one is 1.0. That's the smallest number here. So we say that is 1. Then the next one, which one is bigger than 1.0? That is the closest, like the bigger one, you get it. So the next one is 1.1. So that would be our 2. Then the next bigger one, which is 1.2, will be our 3. Then the next one, 1.3, will be our 4. Then the next one, 1.4, will be our 5. Then the next bigger one, 1.5, will be our 6. Then the next one, 1.6, will be our 7. Then the next one, 1.7, will be our 8. Then the next one, 1.8, will be our 9. The next one, 1.9, will be our 10. The next one, 2.0, will be our 11. Get it? So there are 11 numbers. You are arranging it in ascending order from 1 to 11, from smallest to biggest. You get it? Now we go to the y values. So for the y values, you realize that it's mixed up 8.1, 7.8, 8.7. So that one, they didn't arrange it in any particular order. So you have to do it. So since we did this in ascending order, you have to also do y in ascending order. You can't do one ascending and one descending. You get it? So we are going to do y in ascending order as well. So the smallest. So now for the y values, which one is the smallest? 8.1, 7.8, 8.7, 9.8, 9.5, 8.9, 8.6, 10.2, 9.3, 9.2, and 10.5. Obviously, when we look through, the smallest is 7.8. So that becomes our 1. You get it? So the same column, that would be our 1. Then which one is closer to 7.8? The second smallest. So Now from 7.8, where do we go to? Okay, we have 8.1. There's no number smaller than 8.1. So that would be our 2. Then do we have 8 point something again? We have 8.7. Okay. But we also have 8.9. We have 8.6. So 8.6 would be our next one, which would be 3. So our next one is 8.6. That's our third one. You get it. Then you go to the next one, which is bigger than 8.6. So 8.6, after 8.6, we can go to 8.7. All right, so that would be our 4. Then do we have any 8 point something? So 8 points, we've already done. Okay, so we have 8.9. So that would be our 5. So the next bigger one will be, okay, so 8.9, we go to 9.0. Do we have 9.0 here? Okay, there's no 9.0, right? Do you have 9.1? There's no 9.1. Do you have 9.2? You have 9.2. So that would be 6, right? After 5, we go to 6. Then after 9.2, we have 9.3. So that should be 7, right? Then after 9.3, we go to 9.4. Do you have 9.4? There's no 9.4. Do you have 9.5? We have 9.5 here. So that would be our 8. Then from 9.5, we go to 9.6. Is there any 9.6 here? No. Is there any 9.7 here? No. Is there any 9.8 here? There's 9.8 here. So that would be our 9. Then we go to 9.9. Is there any 9.9 here? No, there's no 9.9. Then is there any 10.0 here? There's no 10.0. Is there any 10.1? No. So you go to 10.2. That would be our 10, right? Then our last one, which is 10.5, that would be our 11. All right, so you are done ranking wise. So we did it from the smallest to the biggest. You get it. So now the next one we go to is the D, which is the difference. So that's the rank of X minus rank of Y. You get it. So this minus this, this minus this, this minus this, this minus this, this minus this. You get it. All right. So now we start with the first one, 1 minus 2. That should give us -1. Then the next one, 2 minus 1. That should give us 1. 3 minus 4. That should give us -1. 4 minus 9. That should give us -5. 5 minus 8. That should give us -3. 6 minus 5, 1. 7 minus 3, 4. 8 minus 10, -2. 9 minus 7, 2. 10 minus 6, 4. 11 minus 11, 0. Alright, so you found for all the D values, which is this minus it. Then you find the last one, which is D squared. So you square all the D values, you get it. So if you are squaring it out, I advise you to put it in bracket if you are doing on the calculator, you get it. Because when you are squaring it, we should get only positive values. When we square, we don't get any negative values. If you don't put it in brackets on the calculator, you might get a negative value. So -1, when we square it, you should get +1. 1, when you square it, you should get 1. -1, when we square it, you should get 1. -5, when you square it, you should get 25. -3, when you square it, you should get 9. 1, when you square it, you should get 1. 4, when you square it, you should get 16. -2 squared, you should get 4. 2 squared, 4. 4 squared, 16. 0 squared, 0. So always the squared values, you take the positive ones. Your D squared shouldn't have any negative in it. You get it? Alright. Now that we found for all of them, we can now find for our Spearman's rank correlation coefficient. And the formula for it is, so represented by RS, something like this. So the formula is 1 minus, then you have a fraction, 6 sigma D squared over N into brackets N squared minus 1, right? So this is the general formula for it. So 6 sigma D squared over N into brackets N squared minus 1. You get it? So it's because of the sigma D squared. That's why we had to find for all this, because of this part. So sigma D squared, it means we have to add all these values. You get it? So now if you're adding all of them, 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 25 is 28. 28 plus 9 is 37. 37 plus 1 is 38. 38 plus 16 is 54. 54 plus 4 is 58. 58 plus 4 is 62. 62 plus 16 is 78. 78 plus 0 is 78. You get it? So our sigma D squared should give us, sigma D squared should give us 78, right? When you add all the D squared values, 1 plus all this, you should get 78. All right, so it means if you want to substitute this, you are getting a Spearman's rank correlation coefficient to be 1 minus 6 sigma d squared. So 6 times sigma d squared, which is 78, then over n. N is when you count all this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you're getting 11 into brackets 11 squared, n squared, which is 11 squared, minus 1. Do you get it? So you can punch all this on the calculator. So when you punch all this on the calculator, you should be getting 0.65. You get something like 0.64545 or something. But remember, we are leaving it to 2 decimal places. So assuming the question has 2 decimal places, you are going to get 0.65. You get it. So it's similar to the first one. The first one, when we use Pearson's correlation, we got 0.70. So this one is 0.65. So you're always not going to get the same thing, but it should be close. You see, 0.70 is close to 0.65. So our answer is correct. All right, so we are done. So that would be the end of correlation and regression. And I'm sure this will be the last video I also do on business statistics as well. So I wish you all the best in your exams. Don't disappoint me. I'm looking out for all of you guys. All right, thank you very much. And don't forget to like, subscribe, comment, and share this video.